Hello class. Today is Monday and I'm starting the day off in Jerusalem. Here you can see a picture of the old city of Jerusalem looking towards the Kotel, or known as the Wailing Wall, which is the most famous and most revered holy site for the Jewish people. The Kotel is the only remaining part of the Second Temple that was destroyed in 70 AD by the Romans. And right above it is the Dome of the Rock, one of the more holy places for Islam in the entire world. So you've got these two incredibly holy places right next to each other. And quite a bit out of sight, but not very far away from here, you would find the Church of the Holy Sepulchre, which for Christians is certainly one of the most holy sites in the world. So in an incredibly small area, you've got three holy sites for the three major Western religions, which is one of the reasons why this part of the world has been fought after so much by so many people. This is another picture of the Kotel, and this is men. The Kotel's got two sides. The men pray on one side and the women pray on the other side. And if you look real carefully in the wall, there's a lot of little crevices in the wall, and people put notes they want to send to God in their prayers. They put in those little crevices. This is a picture of the Old City of Jerusalem taken from outside the Old City. And the last shot I'm going to show you today is Ben Yehuda Street. This is one of the more just active, lively streets in Jerusalem. People walk up and down. There's restaurants, and at nighttime it's a real bustling area. All right, back to algebra. I'm sure you're very excited about that idea. So here's your word problem for the day. These are 5 numbers in scientific notation. What your job is to do is sort them from least to greatest. You don't need to convert them to figure it out. Think about negative numbers versus positive numbers. Think about higher exponents positive versus higher exponents negative, and get a sense of which order you think they'll be in. You've got 2 minutes. Get started. Okay, that's 2 minutes. Let's take a look at the answers. Okay, so what do we have? The smallest number is going to be certainly a negative number, and it's going to be the negative number with the largest coefficient of 10. So, and you've got to look at, see, this is 10 to the 5th, whereas 4.65 is theoretically bigger than, smaller really, depending on how you're looking at this. As you go negative, 4.65 would be less negative than 5.64. But 5.64 is 10 to the fourth, 4.65 is 10 to the fifth. So this is going to be a much more negative number than this. So these are your two smallest numbers. Your biggest numbers are going to be, well, 6.54 is a positive number with a positive exponent. That's clearly going to be your largest number. And then what are we left with? Two numbers with one's got a negative 3 exponent, one's got a negative 4 exponent. So if this is divided by 1,000, this is divided by 10,000, this is going to be a smaller number. And so if you work that out, you can see that those are your, that's least to highest in order. You can actually take them, if you want, and convert them to standard form, and it's really easy to see which are the smallest numbers and which are the largest numbers. All right, today is going to be a little review, and then you've got your quiz on 7, 1, 2, and 3. So let's just go over what we've learned last week. So what's a monomial? Hopefully you all know what a monomial is. It's just a single expression, like 5x squared, 2x, 3, 2x cubed, y cubed, z to the fourth, etc. The only thing that would make something not a monomial if there is a negative exponent in any of the terms, or b, if you had a more than one term. More than one term is not a monomial. Okay, so you're looking for negative exponents and more than one term. Okay, so product of powers. We learned product of powers last week. If you've got a to the m times a to the n, you simply add the exponents. Product of a power of a product, ab to the m, you apply the exponent to both variables on the inside. Okay, power of a power, a to the n, you've taken that whole thing to the m power, you multiply the exponents. So x to the third to the fourth is x to the 12th. Okay? And when you do these type of problems, always remember to keep like items together, constants and different variables, and always keep your order of operations. Okay, dividing monomials, a to the m over a to the m, you subtract, when you divide, you subtract the exponents. That's a to the m minus n. Okay? Scientific notation, you move the decimal point until it is to the right of the first non-zero digit. So if you've got 3.234, you move it to the right of the first non-zero digit. Well, it's already there, so that's pretty much set. So let's find a little better example. Let's say we took 3245.12. So which way is to the right of the first non-zero digit? It's going to be this way. We're going to go 1, 2, 3. Okay, so we moved it 3 places. Note the number of places and the direction you moved the decimal point. Well, we moved it 3 to the left. If the decimal point's to the left, write the number as 8 times 10 to the n. So we'd write it as 3.24512 times 10 to the third. That's how far we moved it. If the decimal point is moved left, write the number as, actually, I didn't write this very well. The decimal point's moved right. Write the number as 8 times 10 to the minus n. So if we had, 0.0023, okay, and we move the decimal point to the right, we go 1, 2, 3 to the right, and we get 2.3 times 10 to the negative 3. So that time we move the decimal point to the right. When you move to the right, you get a negative exponent. When you move it to the left, you get a positive exponent, okay? Now when you multiply and divide with scientific notation, the key is to keep the like numbers together. So take your whole numbers and separate them. So you've got 6.5 here and 8.7 here. Multiply them separately. 6.5 times 8 times 8.7. And then take your the tens, the power of tens, and keep them separate. So 10 to the 12th times 10 to the minus 15th. So when you multiply 6.5 times 8.7, you get 56.55. 10 to the 12th times 10 to the minus 15th is 10 to the negative third. And then this is not in scientific notation because we don't have the decimal point 1 to the right of the first non-zero digit. So we have to move the decimal place one to the left. When we do that, that changes this to 5.655 times 10 to the negative 2. Okay? All right, let's move on. So here are some sample problems. We'll just go over a few of these and get you ready for your quiz today. Okay, so x to the 5 to the 4, you just take x to the 5 times 4 equals x to the 20. R3 to R5. When you multiply, you always combine like terms. So you've got R's and R's. So that's 2 times R to the 3 times R to the 5. And when you multiply with the same base, different exponents, you add the exponents. So that's 2 times R to the 3 plus 5, which is 2R to the 8th. This is a lot more complicated. For a problem like this, you've got to remember your PEMDAS and apply it accordingly. You can start on the inside and work your way out. I think you'll find that easier. So we've got this expression over here. Now this 3 applies to every single term inside. So it's 2 to the 3, g to the 3, h to the 3 times 4 is 12. Now if we look over at the next expression, everything inside of this is going to be squared. So let's just take what's inside of it first, and we'll keep that separate, okay? Minus 2 cubed is minus 8. We can just put it minus 2 cubed for now, but I'll leave that minus 2 like that, okay? Because remember, the cube applies to the minus as well. G to the 4th cubed is g to the 12th. H cubed is just h cubed. And that's all squared still. Okay? So now we've got minus 2 cubed squared. So that's going to be minus 2 to the 6th. G to the 12th squared is g to the 24th. And h cubed squared is h to the 6th. Now let's go back and take the rest of what we had. We had 2 cubed, g cubed, h12. Okay? So 2 cubed, well, let's we have 2 and minus 2, so I think that's not going to work so well right now, but let's actually leave 2 cubed alone, because let's just go over and look at this. Minus 2 to the 6th is going to be what? It's going to be, is that going to be a positive or negative? Well, whenever you use an even number of powers, an even number in the powers, it's always going to be positive, right? And when you use a negative number, it's going to be negative. So this is going to end up being 2 to the 6th. So you've got 2 to the 6th times 2 cubed, that's going to be 2 to the 9th. G cubed times g to the 24th is going to be g to the 27th. Really should exponent do that very nicely. G to the 27th. H12 times H6 is going to be h to the 18th. I think that's it. We have GH, right. That's the answer, okay? So you just take one piece at a time and work your way up. Remember, this is review, and you can get this off the blog later too. Look at some more problems. All right, this is a little simpler problem. It's just straight multiplication right across. Minus 4 times 3 is minus 12. T squared times t is t cubed. N cubed times n to the 4th is n to the 7th. Make my 12 very well. Okay, so you get minus 12 t cubed and 7. All this is about is combining your like terms. Okay, now we've got a little bit more complicated problem. 2 squared is 4. C squared is c squared. D squared is d squared. Inside we've got minus 4 squared, that's 16. C cubed squared is c to the 6th. So we have 4 times 16 is 64. C squared times c to the 6th is c to the 8th. And just d. And that would be your answer. Okay, so just remember, you start with each term take care of what's inside the parentheses. Remember that the exponents outside the parentheses apply to every item inside the parentheses, okay? All right, very similar problem. Minus 5 cubed is going to be minus 125. X fourth cubed is going to be x to the 12. Y squared cubed is going to be y to the 6th. All right, now we've got an addition problem, but we need to take care of, the only way we can combine like terms here is if all the exponents are the same. So I don't know if what's going to happen. Let's see what we get. We'll see. 5 squared is 25. Y squared squared is y fourth. W fourth squared is W eighth. Plus 2 times, we've got to use our PEMDAS and do the exponent first. Okay, so we've got 2 times y to the 4th. W squared to the 4th is W to the 8th. Y to the 4th, W squared times 2 is y to the 8th. So we actually end up with 24 y 4th W 8, 2 times y 4th W 8. So we now can combine them. We can only combine them because we have y and w with the exact same exponents. So 25 plus 2 is 27 y 4th W 8. Remember, you can ask the proctor to stop this video anytime so you can look at what's on the board or ask questions, okay? All right, this is just simply division with exponents, and the rule for division is you subtract, so that's equal to 6 to the 15 minus 9 equals 6 to the 6. Pretty straightforward. And I'm never going to ask you to do that multiplication of 6 to the 6th. Well, that's not completely true, but rarely will you have to do that. Okay, this is y to the 8th. Doesn't come out very well. Over y to the 3rd, which is equal to y to the 8 minus 3 equals y to the 5th. All right, scientific notation. So let's take a look. Remember, we have to move the decimal point, which is starting on 14 million. The decimal point starts here. We're going to move it to the first digit right of the first non-zero number. So 1 is the first non-zero number. So we go 1, 2, 3, 4, 5, 6, 7 places. So we get 1.4 times 10 to the 7th. And we'll take a look at a similar problem, but with decimals. So here we want to move the first non-zero integer is right here at 3. So we go 1, 2, 3, 4, 5. We've moved it 5 decimal points, so we have 3.08. We moved it right, so we're going to make it a negative exponent times 10 to the negative, what do you say, 1, 2, 3, 4, 5. And that's how you do scientific notation, okay? All right, now when you've got problems that include scientific notation, you need to separate out the numbers and the powers of 10. So this is really 7.2 over 8, which is equal to what? 8 goes into that 0.9 times 10 to the 4th over 10 to the minus 3rd. So that 10 to the 4th over 10 to the minus 3rd is 10 to the 4th minus 3, which is equal to 10 to the 7th. Okay? So you've got 0.9 times 10 to the 7th. So, but that's not in scientific notation, is it? Because it's 0.9 times 10 to the 7th. So what's 0.9 equal to in scientific notation? We'd move the decimal point to the right once, right? So that's equal to 9 times 10 to the minus 1, isn't it? Right? Because we moved the decimal point one place. So we've got 9 times 10 to the minus 1 times 10 to the 7th. We combine the last two items and we get 9 times 10 to the 6th. And that would be the answer to that problem. But this last part here, you can't leave it at 0.9 times 10 to the 7th because that's not scientific notation. Okay. Let's try one more. So minus, again, we're going to combine the whole numbers with the powers of 10. So minus 3.6 over 6 is going to be minus 0.6 times 10 to the minus 5 minus 3 is 10 to the minus 8, right? 10 to the minus 5 minus 3 equals 10 to the minus 8. Okay, but now we've got 0.6 times 10 to the minus 8. So I've got to take a look at this term. If I'm going to move the decimal point 1 to the right, I've got 6.0 times minus 6.0 times 10 to the minus 1 times 10 to the minus 8. So I can combine my last two terms again. I get minus 6.0 times 10 to the minus 9. All right, I hope that's clear. If there are any slides you want to go back to, just ask the proctor who's running this class to go back to them. And when you're ready, you can start on the quiz. Have a great day. Don't forget your homework for today is Chapter 7-3 practice. You've already done 7-3 skills practice, so 7-3 practice hopefully you shouldn't have any trouble with. So don't hand in 7-3 skills practice because obviously practice is on the other side. Okay, that's it. Have a great day. I will be back with you tomorrow.